Let us take an example of collision of rigid body, say the rod which moves with velocity v and angular velocity omega. Initially, let it be v naught and omega naught, and it is struck, is collided by or hit by particle of mass small m. Rod mass is capital M. Length of the rod, let it be L. From center of mass of the rod to this particle distance is let B. The question is, write the relevant concepts and equations to obtain the linear and angular velocity of the rod just after the collision by taking necessary assumptions. E is the coefficient of restitution. If you analyze during the collision of the rod and the particle, there is an impact or impulsive force acting on the rod, that is plus n, and another impulsive force is acting on the particle, that is minus n, equal and opposite and collinear. The impulsive forces are equal and opposite and collinear, therefore they cannot produce a torque about any point. Since N1 and N2, let it be N2 and this is N1, are equal, opposite and collinear, their torque, that's equal to the sum of the torques produced by these two forces, will be equal to 0. Since net torque is 0, angular momentum of the rod can be conserved about any point. Write the relevant concepts. Conservation of angular momentum holds good. Let us assume that the rod will get an angular velocity, will change its angular velocity to omega and its linear velocity to v. Yes, just after the collision. This is just before collision. This is, they are interacting during collision. We can see that these two forces are equal and opposite. Therefore, the net force acting on the rod will be equal to N1 plus Rod, it's not rod, net force acting on the system. We have to choose the system. This is the system. Net force acting on the system, that is rod plus particle on the system. What is the system? Rod plus particle. Net torque acting on the system, rod plus particle. On the rod there is a net torque about any point, about the center of mass A. And the particle also experiences a net torque about the center of mass point. But if you take this as a system as a whole, rod plus particle, then the net torque will be 0 about any point. So, net torque will be 0. Hence, the total angular momentum will be conserved about any point for this system. We have to define the system, that is rod plus particle as the system. Net force acting on the system is 0. Therefore, linear momentum of the system remains conserved. So, next concept is conservation of linear momentum. And the third concept, during the collision, we can apply Newton's empirical formula. Minus A into velocity of approach is equal to velocity of separation. This is the third concept. And the fourth concept, to find the velocity of this point, we need to apply the concept of the kinematics of rigid body. Kinematics of rigid body. Velocity of this point P is equal to velocity of the point P with respect to C plus velocity of C, where velocity of P with respect to C is omega L by 2, omega into B. So, these are the underlying concepts. Concept number 1, conservation of angular momentum about any point. Concept number 2, the linear momentum conservation about any point. And concept number 3, Newton's empirical formula. And concept number 4, the kinematics of rigid body, because for this we need to calculate the velocity of the colliding points. It's nothing to do with the center of mass velocity for this impact, because the impact doesn't take place at this point. Impact is taking place at these 2 points. So, we need this point velocity, not this point velocity. So, we have written the relevant concepts. Now, we have to write the relevant equations based upon these concepts. Well, so we need to write the equations now. This is the initial position or initial condition. Say V naught, omega naught, and let it be velocity of the particle initially is u naught. Yeah, just after the collision, let it velocity be v, angular velocity is be omega, and velocity of the particle just after the collision, let it be u. Angular momentum conservation. Concept number 1. Reference point. You can take any reference point, but if you take the reference point any point on the line of motion of the center of mass of the rod, then you can get some mathematical advantage. That mathematical advantage is, with respect to this point, the angular momentum of the rod center of mass, the orbital angular momentum of the rod with respect to this point will be 0, because the center mass of the rod, let it be the fixed point or reference point. This is the RC cross VC will be equal to 0. So only we can write the spin angular momentum of the rod about this point. Well, final angular momentum is equal to initial angular momentum. The final angular momentum about this is equal to its RC cross VC is 0. Only we have to write the spin angular momentum, that is M is capital M, L square by 12 into omega in positive. We have taken omega in positive z direction. Spin angular momentum we have noted, orbital angular momentum is 0, and angular momentum of this with respect to this, that's equal to M u into v, in which direction? R cross mu, in this direction, outward. And R into mu into sine theta, small r sine theta is nothing but b. Directly you can write mu into b in positive z direction, plus just you can write, or you can write k cap, no problem, plus k cap. Initially, the angular momentum of the rod, your initial condition, this is the final condition, m L square by 12 into omega naught. I have taken in positive z direction, the direction of omega, and orbital angular momentum initial about this point will be 0, and particle initial angular momentum about this point is equal to m u naught into b along positive z direction. So next step you are getting m omega L square by 12 or ml square by 12 omega minus omega naught will be equal to small m u naught minus u into b. Equation number 1. Next concept is the conservation of linear momentum of the system, rod plus particle. The particle's linear momentum is mu naught, positive x direction. Rod's initial linear momentum is mv naught along positive x direction. Just before the collision, just after the collision, this will be equal to mu I cap. Linear momentum of the particle along positive x direction, and linear momentum of the rod along positive x direction. So we will get mu naught minus u is equal to capital M v minus v naught. Second equation, based upon the conservation of linear momentum. The third equation is Newton's empirical formula, which states that minus of E into velocity of approach is equal to velocity of separation, where approach velocity can be written as, let it be 1, this point is the colliding point, point 2 and is point 1. The approach velocity is the relative velocity between the colliding points along the line of collision. just before the collision, and separation velocity is the relative velocity between the colliding points along the line of collision just after the collision. So this is u naught minus, let us assume that its velocity is v2 and its velocity is v2 dash. U naught minus v2 I cap, and v separation is equal to u naught minus v2 dash I cap, where v2 and v2 dash can be given by, or you can just write minus a u naught minus v2 is equal to, this is separation, that is u minus v2 dash. v2 and v2 dash can be calculated by using kinematics of rotation. v2 is equal to velocity of to with respect to c plus velocity of the center of mass. So v2 can be written as velocity of 2 with respect to c, this is equal to b into omega I cap plus center mass velocity, in this case is v naught I cap. Therefore v2 will be equal to b omega or omega naught plus v naught, and similarly v2 dash can be written as b omega plus v. So we have 5 equations and 5 unknown quantities. The unknown quantities are omega, v, v2, v2 dash, and u. 5 unknown and 5 equations, and these are all known quantities, all given initial parameters, given quantities, initial quantities, v naught, u naught, omega naught, and of course the dimensions b, L, mass of the rod, mass of the particle, all these quantities are given. These are the initial velocities, and we need to calculate the final velocity, omega, v, and u. So to find omega, v, and u. So this is a qualitative problem, and in this problem we wrote the concepts. Number 1 concept is conservation of angular momentum. Second concept is the conservation of linear momentum, and the third concept is Newton's empirical formula, and the fourth concept is kinematics of rotation. Vp is equal to Vpc plus Vc. This is the kinematics, where Vpc is equal to b into omega, and directions are given. So in this way you can solve the problems of collision of the rigid body with the particles.